In the last video, we learned 4 rules for assigning significance to a digit within a number. And the way we applied those rules is essentially to look at a digit, apply the 4 rules, and if none of the rules apply to the digit, then by default, it was not significant. In this short video, I want to give you an alternative perspective that really focuses on assigning a lack of significance to a number. So what's the criterion for a digit not being significant? In some ways, this is a more intuitive understanding of why a digit is significant or not, and it's a little bit easier to apply, although it does require an understanding of scientific notation. The basic idea here is that if a digit can be removed when we write the number in scientific notation, then that digit is not significant. So translating a number from the typical form to scientific notation allows us to remove all of the non-significant digits from the number and essentially shove them into times 10 to some power. So to show you how this works, consider the number 4972000. To write this number in scientific notation, we can notice that the 4 is in the millions place, and so we can write it as 4.972 times 10 to the 6th. Notice that the 3 trailing zeros at the end disappear. Really, the only purpose of those zeros was to show us, sort of indirectly, that the 4 was indeed in the millions place, in the 6th place. So we can lose those zeros without losing any information about the value or precision of the number. Really, the precision ends at the 2. The 3 zeros that follow are just placeholders. So in this number, there are only 4 significant digits, and in fact, that 4.972 is given the name significand. And that's really informative in the sense that it shows us that the significand really captures all of the significant digits within a number. This also explains why significant digits need to come in a continuous string, because of course the significand has to be a continuous string of digits, and everything that shows up in there, including zeros that might show up between significant figures, is significant. There is one exception that has to do with that rule number 3 from the last video, the relatively arbitrary rule. Zeros on the far right after a decimal point are considered significant. We do write these in the significand by convention because they illustrate additional precision. So for example, the number 48.200 has 5 significant figures. The 2 zeros at the end after the decimal place indicate additional precision, and so we do carry those over into the number written in scientific notation.